Today I want to show you how you can set up a material that looks from this to this inside Unreal Engine 5. I'll help you set up a material which is going to be using a tessellation and displacement for nanite, and on later parts we are going to continue to expand it and add extra functionality like wetness, more layers, or also optimizing it so that we can use that for games. The material that I'm going to show you is going to be set up mostly for cinematics, as it's going to be a little bit more expensive, but we will do an optimized version where we can achieve a similar result inside in-game. Now we are inside Unreal. I'm using Unreal 5.6, and instead of creating a master material, we are going to start by making actually a material function. So we are going into our content browser, right click, material, advanced, and then material function. I'll type it mf and material A. The reason why we're starting with the material function is because inside the master material, later you will see, we will combine all these things and it will make just things a bit tidier, nicer. And inside the material function is actually going to be the very base setup of how exactly we control each of the different layers that we want to build. So opening now the material function, here we have our result. But we also want to start with an input because there are a couple of things that we might want to control. So right click and we're going to type input, function input. Here inside the input name, I'm going to type it material attributes and then change it from function input vector 3 to material attributes. We are going to drag from here and get material attributes. When we have the material attribute selected, here on the attribute get types, we are just going to click the plus button. Let me expand it so we see what we are doing. So we need base color, we need metallic, and here on the index 4, we are going to change that to be displacement. And also because we don't need the specular, we are going to change the specular to be normal. So in this case, we have base color, we have the metallic, normal roughness, displacement, and the emissive color also is something that I'm just going to change to ambient occlusion. Now let's start setting those one by one. We will start from the base color. So for the base color, we don't want only to have our texture, but as well we would like to be able to desaturate it and as well tint it in a different color. So first I'm going to add a desaturate node. And here I'm going to hold 4 and click somewhere. We are going to create a vector 4 node over here. Right click, convert it to parameter because we want this to be able to change. Here we are going to name it material A, albedo control. This way we know for which material, because we're going to have a couple of different layers into the material. We will take the red channel and 1 minus. We want to invert it. 1 minus is inverting it, and put that into the saturation. From the desaturation, we are going to drag and get a multiply. Now we are taking the green channel into B on the multiply, and then we can hold M and get another multiply. I'm going to copy and paste our vector 4, and here we are going to rename it. So it's going to be material A albedo tint. We're taking the full node like all the RGB, and this is going into B. And then from this multiply, we are taking a power node, which inside the exponent, we are going to connect the blue channel. So this is everything that we need for the base color. I'm just going to move that a little bit higher like this. And here we need to put a set material attribute. We're going to do exactly the same layers like we have here. So I have the base color, metallic, normal, roughness, displacement, and last ambient occlusion. And now the base color, we hook it over here. And already our set material attribute is going into our output result. Now let's do the metallic. So metallic is going to be a bit simpler. We just need a vector 1, right click, convert to a parameter, material A metallic, and we want to hold A to make an additive. This is going into B, and then this is hooked into the metallic value. After the add, we just connect it to the metallic on the other side. To start a little bit organizing already our things, let's put some comments so that we know which section is what. I'm going to select all the elements on the top, which are for the albedo, press C, and that's going to create our comment. So here I'll make it albedo. Here we make it metallic. Now we are doing our normal map. So for the normal map, we need to find flat normal. We're connecting the normal over here. Then holding 1, we are creating a constant. Right click, convert to parameter. Material A, normal, power. I'll name it like this. This note is how flat our normal map is going to be. So if we leave it on 0, this means that there is no effect. But if we increase it, so if we example this is 1, this means that it's going to be completely flat. So to make it more clear, I'm instead of normal power, actually going to name it normal flatness. So 0 means we will have the whole intensity, 1 is going to be completely flat. And then this goes into our normal. Again, we are making a comment, normal. Next one, we have our roughness. So for the roughness, we first need to make a mask component. And for the mask component, we want to take only the green channel. This is how we're gonna set up as well our textures when we're packing and doing all the things afterwards. After the mask, we are taking a cheap contrast, holding 1, creating a vector 1, convert to parameter, material A, roughness, contrast. And this goes into our contrast. And then for the roughness, also we want not only to adjust the contrast, but as well the intensity for it. I'm going to add a multiply, again a vector 1, convert to parameter, material A, roughness, intensity, and we are hooking this over here. So I'm going to leave this on 1 by default, so we won't take exact values that are from the texture, but again we will have the option to adjust it later. And this goes into roughness, comment it. For the displacement, we want to do something very similar to the roughness. So I'm just going to copy all of that, but we are going to change the mask. And also we are going to add additional parameter, which will be a switch that will allow us to either enable it or disable it. If this case, if we want the material and the function to be a little bit cheaper, we can always disable it and use the case for this material for something else. So I just copy pasted all the nodes from our roughness, and now this, instead of our green channel, we are going to use the blue channel, and here instead of a roughness, it's going to be displacement. Same goes over here, connect the displacement. And now we want to use a switch. So for the multiply, we drag it and type switch. And we want static switch parameter. And here we are going to name it use displacement. For true means that we are going to use the logic. And then if it's false, we just want to make a static value of 0. This is going to be like a constant value of 0. This is means that we won't use anything, so there is no displacement. And the default value, we can set it here. So by default, this means that it's going to be disabled. And then we will have the option in the material instance to click it and have the displacement parameters and everything enabled. So the displacement, we are connecting it here, but we also would like to have a second output, which is going to be height. This is the whole material, all the material attributes, but we can copy and then paste the result. And this result here is going to be output, and we just name it height because we would like to get from the displacement as well height information. That's going to be very useful for us. Again, selecting everything, commenting, and naming it displacement. And the last part we need to set up is our ambient occlusion. Since again, it's a similar logic to what we have here, I'm just going to copy one of these, paste it, and now we will change a couple of things. So first, we don't need the cheap contrast. We need power node. Second, here we are going to use our red channel. This goes instead of to a multiply, it will go into an add. And let's rename these parts here as well. And for the intensity, because currently if we increase the value, this is going to go towards whiter, which is actually going to decrease the amount of occlusion. So we need to invert it. So 1 minus, and it goes over here. And then this goes into our ambient occlusion. And that's pretty much it. This is our material function. This is how we would like everything to be set up. We will use that now inside our main material. And also a bit later in the video, I'm going to create duplicates for the different layers. So this is our layer A. We can make layer B, C, and so on, however many we need. I think that a good number for, at least in my cases, is usually 2 or 3. 3 layers is pretty good. You can do 2 different materials, for example, bricks and then like a painted brick, so we can blend in between those. And then a third one, which can be like a dirt or something else. So 3 layers usually is a good one. Now that we have the way how we're going to adjust our material parameters, let's set up another material function. And I'm going to make it material A base. So the base is going to be where we set up all the textures and everything else. And what we just set it up is the logic of how we are going to adjust all the things. I set it up this way because it's useful now that we have here everything aligned, so we know how we would like to pack our textures, and pretty much we just need to follow the logic of how we're going to do the adjustments and then set up how exactly we are packing our textures. Of course, we can do it vice versa. For me, this just is a little bit simpler way of making it. So here in this function, we are going to start by making a couple of slots for our textures. I'm going to right click and type texture, and what we're looking for is texture object parameter. Again, this is material A, and we will do the albedo. I'm going to copy paste this and make here normal, and one more time we are doing for the metallic. And last but not least, remember how here we used different channels. So we have green is roughness, B, or the blue one, is our displacement, and I actually didn't connect this one. So ambient is our red channel. The reason why I packed it in this way is not only because I like it, because we are going to use some textures from Quixel, from the Megascan library, and this is the way that they pack as well their textures. We are going to copy paste and create a new slot, which is going to be for A, R, D, or the way that we packed our ambient, roughness, and displacement. Now let's right click and put a texture sample. We don't need to make those parameters. We have the parameters over here. So this is where our slots for the different textures that we have are going to go. We'll set that in a second. And now from here, we just go into texture like this. Let's copy paste another one, normal, same thing. This one is for our metallic. And last one is for our combined map. Let's set up some coordinates. So right click, texture coordinates. This is going to be for our UV tiling. We are multiplying it, and we are taking a parameter, convert a parameter, material A, UV tiling. I'll put that one as default, and then this gets connected to all the UVs. Now let's add a node if we want to use metallic or not, because maybe in most of the cases we actually won't have a metallic map. So I'm just going to drag from the alpha, and we'll put a switch. This is because if I would like to pack it, I'm going to pack it inside the alpha of some of the textures, and we are naming it material A, metallic map. We're creating one more parameter, which default value 0, convert to parameter, material A, metallic power. So by default, I'm just leaving it like this. We are going to take parameter value of 0, which means that the surface is not going to be metallic. But if we tick it on true, then we will use a texture, and we need to have a texture input over here, which is going to take it from the alpha. Now the last bit is we need to create a little bit of functionality if we want to use such map or not. Maybe we sometimes have like a very simple version of the material. We don't want to have all these textures. And what I'll do is copy this parameter, and instead of naming it what we have here, I'll do material a use ARD map, connect the RGB into true, make it default value checked out. And here, because we have 3 different values that we need to set up for each of the channels, I'm going to need to copy paste this few more times just so that we can break it down better and connect this into all the 3 values. And if not, we need to set up some material values over here. So that's going to be our red channel, which is material AO, and then the green channel is material A roughness, and last one is displacement. So these values, they go into our false. Now after the parameter, if we're using those, we need to break out float 3 component. We need 3 of these. And we are going to take for each the correct channel. Now it's a good time to start setting up the material attribute so we can start putting everything together. I'm going to right click, make material attributes. And here we already have the metallic, which we're just going to hook up in here. Also, we have our albedo, which goes into the base color, and then the normal map, which we are connecting to our normal. And now these elements, they go accordingly. So first one is our ambient occlusion. So the first one goes to our AO. Second one is our roughness. And the last one is our displacement. Our make material attribute goes to the output. Okay, so all of this that we set it up now is for having our material UV based. So this is if we don't use any world align material. Now on the bottom, I'm going to set up a world align function, and then we are going to add a switch, which is going to tell us, do we want to use world align or we don't want to use it? In this case, the master material will be usable for both props that are using world aligned stuff, or you already made unique UVing for them, and then you will be able to use the UV sets that you already created. So this part, I'm just going to move it over here because we are doing the functionality on the bottom. Let me just slightly organize it like this. Select it, comment, and we are doing UV based setup. So we know what is this for. And then here on the bottom, we will do our second setup, which is going to be world spaced. So some of the things we can directly just copy from what we have here. So those 3, we are copying them on the bottom and then connecting same sample. So this goes into our, the first one goes into our albedo. Second one was our normal map. Then the next one was the metallic. And then we are taking our material use ARD maps over here. And instead of doing any sort of breaking before that, what we are doing is just taking them directly into the true and also copying the same values from before in case that those are false. Now what we will need to do for this portion here is going to be a functionality. We will do a material function, which is going to be for the world aligned textures. For now, we're just going to save it and open our content browser, right click, material, and material function, mf world aligned texture. And here we will first start with our inputs. So I'm going to put an function input. The first one we are going to name texture side Y. Second one is going to be texture side X, and Z for the last one. I'm going to change those into vector 2s. We don't need to be vector 3. And on the bottom, we are taking a world position. And on the world position, we, by default, it's including material shaders. So we want to use the absolute world position, but excluding the material shader offset. And we are going to put another input on the bottom, which is going to be a world position divisor. We will leave it as it is. And now here we are taking an input function. And here we need as well to take just the world position. We will divide it by the divisor that we just created on the bottom as well. And now we need to start assembling all the other parts also. So here first I'm going to create a couple of component masks. This one is going to be red and blue. Then we need another one which is going to be the green and blue. And last one is going to be green and red. We need our dividers to go into all the masks. We will add an additive, and now we are connecting all this into B, and then another one which we need to divide. And here what we will need to divide it by is going to be all the different textures, but in this case we are going to use as colors for all the different sides. So I'm going to copy all of that, and instead of a vector here we need a scalar. We will need the ABS for all of those. This goes into a multiply, and then those parameters go into each of the divides. We're going to take now another vector input. So for the vector input we are just typing input. We'll use a vector2, and this is going to be our global texture scale. And here we are going to take a function which is default function inside Unreal. It's called scale UV by center. I'll just copy that a few times because we need to do it for all the different inputs. So this goes into the UVs, and then the dividers go into the texture scale. All of this we also need to be able to control our contrast, so we will make a bit of an extension of the functionality on the bottom. And here I'm going to take the vertex normal. I'm going to use an input function, so this needs to be vector3, and we are naming this world space normal because this is the world space normal that we are taking here. And we need another input on the bottom, which is going to be a scalar parameter, and we are going to name this projection transition contrast. Here we are going to need two mask components. So from the world space, if you know the normal maps, they usually the red and the blue channel hold most of the information, and then our green channel is not so interesting. So we are just going to take those two, making an ABS afterwards, and that goes into cheap contrast. We will need two of those over here and the second one over here. One more time we need to mask the results just to make sure that we get the correct components here, and for the next one we need the red channel as well. And now we are going to add a texture object, hook that into an input. This is going to be our texture object input, and here we leave it texture 2D. Already Unreal knows what it's doing since we dragged it from the texture object. We need a texture sample, 3 of these, because we are going to separate it and then lerp in between them so that we combine the whole tree planning. This goes into text, to our texture input. Now we need 2 lerps. We can hold L and just create the 2 lerps and start hooking up all the different things that we have over here. So we are taking the first texture, and this goes into B, and our second part goes into A, and then this lerp goes into A, and the texture goes into B. And for the alphas, we are going to use the world space that we just created. And here for the UVs is going to be all the functionality that we previously made for the world space. Now for the outputs, we are going to change the results slightly. So we need an output which is going to be just X and Y texture. So this is if we are using a texture that's UV'd. So we hook this one in here. Then we have same one, but we do X, Y, and Z. In this case, we use the whole tree planning, and we also need just a Z output, which we are going to get directly from our texture here. So this one, as you see, it's connecting to our Z, so we are just getting our Z output coordinates. Okay, and we can apply and save this, go into our base, And now I can drag and drop this material function and start hooking up some of the things that we created previously. So going back to our function, drag and dropping this here, I see that we can slightly optimize it. So we can remove actually all of these because we don't need them, and directly take from the material, and this goes into our texture object. Now we need to create some of the other functionalities so that we can hook all the other parameters in here. So just below this one, I'm going to create a new scalar parameter, and this one we are making it a material, a global scale. Let's leave that on 1, and then the other one we are making material a triplanar transition contrast. Then we are creating a vector 4, holding 4 and clicking somewhere, convert to parameter, material a texture scale. This is so we can control it into the different dimensions, and we can stretch the texture and so on. And the other one is not scale but offset. And now we can start connecting all of this. It's going to become something a little bit overwhelming, to be honest, because we need to do that for each of the different channels. It won't be very complex. So global scale, we just need to find the corresponding pin. So we have here the global texture scale. And now here you can see the texture sides. For the texture sides, we have two things. One is the scalar one, where the scalar one is going to be the sizing. So this one, the texture scale, and the offset is the ones that are not scalar. So the texture X, Y, and Z are going to the bottom one. So red one is X. This is going into here. Then we get the green one for Y, and the blue one that goes for our Z. We do exactly the same thing, but instead of connecting it to those, we connect it to the scalar. So we do red one goes into X, Y, and this one goes into Z. Last but not least, we need to hook our contrast. This goes into our projection, contrast. So all of this logic we will need to do for all the different textures that we have over here. So this means that I'll need to copy paste it. So now we take the normal map, we do exactly the same, and we are going to do same for the metallic and also for our ARD maps. After hooking all of that up, you should end up with having something like this. So we hooked each of those into its separate, and then all the correct parameters and everything else. Now it's time to start doing some masking and also connecting everything so that we have a correct output. First, I'm going to take make a material attribute and duplicate that over here because we are assembling a second version, and we'll do a switch if we want to use the world tile or we don't. I'll need this one one more time down here, and let's start hooking from the very top. So for first, we're going into our albedo. The X and Y we are connecting here, and the X, Y, and Z goes over here. Then second one is our normal map. So here we will need to add couple of masks. Right click, mask component, and the first one is green, and then we will duplicate it. So we take the X and Y over here, and this one goes here. So after the masks, we need to copy this parameter twice for the switch. So the one from X and Y goes in here. And then we have the second one where we are connecting this into true, but also we are connecting this into false. So we want to mask it when it's true, but we don't want to mask that if it's false. The one that's going just from X and Y is going to be connected here on the bottom one, and then this one goes on the top one. Next is the normal. Again, same thing. The one that's just X and Y, it goes on the bottom, and the X, Y, and Z goes into the top one. We want to get the same functionality, and it's going to go for our displacement. So this is our ambient occlusion, our roughness, and our displacement. So we are going into our displacement, and for the displacement, instead of G, the green channel, we want to use the blue channel because this is how everything is packed. The X, Y, and Z goes to the top into the displacement. and then the other one goes to the bottom. Here on the displacement, we want to change one thing, because we don't want to have like we don't want to take a different value. So we need to create a scalar, and we are just going to hook the false into here like that. And then we are copy pasting same logic for our ambient occlusion. But this time for the ambient occlusion, we are using the red channel, ambient. And let's take our metallic values. I'm going to take what we have here on the top and paste it down. So we need to track though. This is going here. So this is for our metallic. And this is for our normal. I hooked it incorrectly over here. So we change that like this, and here this. And now we need this thing for our metallic maps. This goes here like that and like that. Okay, expanding a little bit on top of it. So here we would like to give the option that this displacement is not always on. So what I'm going to do is make a switch and name it use displacement. If it's true, we just hook it like that. If not, we just take a scalar like this and make it into 0. And now let's set up a switch if we want to use the world tiling. So use world tie material. I'll make that true by default. And let's start setting some outputs. Here we have the material attribute UV. And then we have another one which is going to be for height. We need I'm going to copy the top one. We need the material attribute X, Y, and Z. And another one which is just X and Y without the Z. This one is already hooked correctly. Then here for the height, we need to take the displacement and we're going to put this into false. So if we are not using the world time material, this is what we are getting. And then if we are using the world time material, we will need to get the different height, which is from the tree planner. So here we just need to find which one it was. We have, I think it was the very last one. So here we just need to take B, and this goes into true, and then that's going to be our height output. Let me just expand a little bit our functionality, actually change a little bit our functionality. So here we need to change the display. If we don't want to say if we use that or not, but instead what we want is to use the world displacement. So sorry, the use displacement. So I'm just going to copy that one. And what we are doing is this goes like that, false, and we need one more time. Same thing, like that. And I will need to rehook this stuff. So X goes into the bottom one, and the X, Y, and Z goes on the top. And now the top one is our X, Y, and Z, and our bottom one is just X and Y. And that's pretty much our material function that we need. We can now make a master material and start hooking all these functionalities that we just created. Content browser, right click, material, M, world, tile. First thing that we are going to change, we don't want to use and hook everything in here. So we are going to use a material attribute and hook everything at the end there. Now I'm going to drag and drop our world material A base, make a switch. And here it depends of what exactly we want to use. So if we want to use just X and Y, that's going to be on the true, and X, Y, and Z going to be false. Another switch we'll make for use world tile. This is the same thing that we had here. So we'll use world tile material. This goes into true, And if we don't want to use the world tile material, we go to false. So by default, I'm going to set it to true. Now, as a next step, we need our functionality to do the adjustments to all the textures. This is the very first that we had created. So this goes here and this goes connected like that. And then we will do a switch for this as well. So switch parameter and use material A adjustments. Result goes into true. If not, we just skip that and we hook this directly. And we're gonna need one more node for our height. And if we don't here, we need to take this height component. If we want to start adding more layers, what we need to do is we need to have the material A base duplicated, and we can make a material B and then material B base. So just gonna need to come over here and rename some of the stuff. Like for example, this is not going to be material A, but it's going to be material B. So this case, everything gets not mixed up as parameters and uses correctly. And then we hook up the material B same way that we did A. And after that, we're going to use a blend. So let me show you quickly how we are going to do that. So we get, let's say, material A, and this one, we are just duplicating it and calling it material function material B. Now going inside here, we just need to change every place where we have the value. So for example, this is not going to be A, but it's going to be B. Same goes over here. Roughness. The ambient occlusion as well. I didn't hit. I'll need to go and update it here to have A. And this makes now the values not gonna mess up and mix in between whatever we are changing. There are a few more over here. Just make sure to go through all the values, make sure that all of them are changed, because if any of the values stay as they are, we are going to affect that with changing of the parameters. And now this large functionality that we also created previously, which is our material A base, I'm going to right click, duplicate, and make it material B base. Similar thing, we just go through all the different parameters, change it from A to B. After renaming all of that, we are dragging our material B base, pretty much doing exactly the same setup. So I can just copy paste all of that and drag and drop the material B attributes over here. So this goes result like that, and this gets cooked here. We have the X and Y and the X, Y, and Z, and this one goes into UV. So now we have our material A and material B. Now it's time to start blending it. We're gonna need to make one more material function. Going into content browser, again, materials and advanced material function, MF and blend materials. What we will do is we will use height as information to blend things. So we are going into an input. That input gonna be a scalar, and height, this will be height 1, and then we will do height 2. So we will take the two heights, compare it, lerp in between, and that's how we're gonna compare those. We will remove like saturate. We need a lerp, holding L and creating a lerp. And then we are doing a second height, so height 2. Again, leave it as a scalar. We're going to put a input which is to mix the both, again into a scalar parameter. That goes into a multiply, and this is our B, and this is going to be the alpha. Now we are going to add also an information for vertex paint, because here how we are assembling, we are going to blend in between, but then we also are going to add a vertex color, which we can paint where exactly the blending is happening. So we are taking that and making a 1 minus, multiplying it, and we will multiply it we'll do an input, and this we name contract expand or contract, and that's going to be also a scalar parameter over here. This goes into subtract again. We need an additive node where we're gonna connect the vertex color, taking a vertex color, and we need one of these. And put, and here we do vertex color multiply. We need to multiply it by 2 instead of just 1, and that goes into our subtract. Another input, and here we make a blend contrast. Again, change it to scalar like that. Okay. And now we need to set material attributes, and this is, we are just going to take one thing, which is going to be the world displacement. This goes into an input. That this input, we will name it as material attributes 1. So this is one of the materials, and then we'll have a material attributes 2, which is going to be the second one. When we blend it, we're gonna use a blend material attributes. So we have A, B. We are going to use the result from what we calculated here on the vertex color as our alpha, and get material attributes. We want to add here a displacement. The displacement, since we have it on just one of the channels, so we are masking that, and just gonna use one channel. I'm gonna copy that output, and here this result is going to be our height, and here this one will be our material attributes. All right, and we can go back here to our main material, the master material, drag and drop the material function blend. We can hook those, and then we just need to create the vertex color as well. Here what we do is we are taking our pin from the material adjustments into attribute 1, and from the second one we take it into material attribute 2. We do the same for the height, so height 1 and then height 2. We will do a separate control for the expand and the contrast and the mix as well. Now let's add the vertex color in. So here we are adding vertex color. I'm going to do a switch and enable vertex blend. We will copy paste this a couple of times because we will need it for the different bits and pieces, because we will separate the different channels. So connecting those properly. We will put a value of 0 in case this is false. Let me just reorder those so that we have them properly on the channels. We take the red one, and the red one we put it here into the vertex color. And now we need to create a control for the mix, expand, and blend contrast. So we are making a vector4 parameter and convert this to parameter material A to B blend control. We take the same switch with the enable vertex blend, enable that. If not, there is a 0 here. We need to do a split component. Again, this is a function that comes from Unreal by default. And then we need to connect the different channels depending on where exactly we are mixing. So we have the red one goes into our mix, green one goes into our blend, and the last one goes into our expand. And as the last point, we take the material attribute and connect it to our material. At this point, what we are doing is going to be testing the material. So I made a material instance by right-clicking on our master material and create material instance. This is how your material instance should look like. Like, I already have some different parameters and things that I changed here and there, assigned some of the textures. So these are textures that I got from Quixel just so that we can showcase it. And I got a wood. So we have the albedo, the ARD and normal map, and same setup for ground texture. We can enable the material triplanar transition by adjusting the values. You can see that we can make the transition either like very harsh or like blend nicely. So for such cases, yeah, of course, we will get such thing because we are projecting the texture from all the directions. Of course, we probably won't have such like spherical shapes, or we can do a little bit more blending in between materials. So there are other ways how we can hide those transitions. But if you have assets, for example, like a column or some other assets, majority of the cases, this should work just fine. Now the next and last step that we need to do is you can see that at the moment there is no any displacement, so we need to enable that. Currently this is something that we need to manually enable with some of the settings inside Unreal. And for those settings we can open where we have created the project, go to our configs and then open default engine. You can either edit this with the notepad, or in my case, I have Notepad++, makes just things a little bit more organized and a little bit easier so that we can go through different settings and setups. You can see this portion right here, which is for our ray tracing. So right under the ray tracing, we just need to paste 2 lines. I'm going to put those lines down in the description so you can just copy them. But the lines are enabling nanite, so it allows nanite tessellation, and also it sets a default tessellation of 1. This I'm going to save it, and we will need to restart the engine as well. From this point on, I changed a little bit the textures, did some small adjustments by enabling our adjustment parameters. The textures that I've been using are all from Quixel, but of course you can create your own, and I'm going to show you in some of the next videos as well how we can expand the functionality, also how we can create our own tileable textures, either from scans or how we can sculpt them and bake them. Subscribe and follow so that you don't miss any of the other parts, and leave a comment if you would like me to cover other topics. Thank you for joining me today. See you next time.